been wanting to do this for a while, so what I want to do is create courses and online material. I used to do this quite a bit, actually. I've written many courses, probably 30 plus courses. I used to travel the country 20 some weeks a year. The weeks I wasn't traveling, I was working on new courses or doing consulting, and I kind of got out of the habit of it. I wanted to get back into it. So this is some of the types of things that I wanted to talk about. There's many little projects I've done this year where I've created this one's a ring buffer. There's another where I create a bloom filter. Wow. Bloom filter, a hash, a heap rather, hash map. So this is a little project that I did. I wrote so this is just a plain old link transfer queue, just to give an example. I have an executor service. I'm going to start 2 threads. One's a writer, one's a reader. I'm going to see how many of these 30 million records I can put through in a short period of time. So here's my writer thread. I create an executor service in Java, just that's plain old Java. This essentially is my writer thread. I create a latch so that I know when this stuff is done. Here I am adding items to the record. If for some reason that didn't work, I do an offer. An offer will wait 10 seconds until it can write that data. So it's going to add it as fast as it can. If for some reason it can't add it fast, it's going to wait. This was really more important if you're using, instead of using a link transfer queue, if you use like an array blocking queue, that would be important to sort of wait if the buffer fills up, if the queue fills up rather. And then here for my reader, I'm pulling the queue. Again, I'm going to wait up to 10 seconds for that first pull, and then every time, so there we do a latch countdown. And if you recall, a latch is a construct from Java utils concurrency, and when this counts down the number of records, 30 million, that means we received all 30 million records. So this is counting down every time we get a record that's not null. This is if for some reason the writer is slower than the reader. We'll wait up to 2 seconds for an item to be in the queue before we move on. And then lastly, down here, I'm going to wait 10 seconds for this latch, so for all 30 million of these to come through. If the count is 0, then I'm going to calculate how long that took. So let's just run that. So that ran in 3 seconds. 30 million records across the queue in 3 seconds. That's 10 million reads a second. Now, oh well, this is a ring buffer, and I'm going to keep it real simple. I'm going to keep generics out of it. This is a ring. A ring is just an array. So what we're doing is we're going to have a writer write on one side of this while we're reading on the other, and then as the writer gets to the end, this is where the ring comes in. It's just going to start over at the beginning. So we're going to need what ring number we're on, right? So if I'm on the 5th ring, that means I'm 128,000 times 5 positions out there, right? And then the index is where am I at in the current ring. Now, as you can see, if you've got a reader and a writer, the writer can't be on ring 7 while the reader is on ring 4, because then the writer would have written over what the reader is reading. So we need a location for the reader and the writer. We need to make sure that the writer is always ahead of the reader, and then think of the ring as kind of infinite. Well, 32 million times 128,000, so not quite infinite. We should probably have some logic in there to set the ring back to 0 once once it goes negative. I don't think I have that logic in there yet. It hasn't been an issue, but obviously this doesn't have all the edge cases done either. So this is a location. It's a ring location. We're going to store in an atomic reference, which is a non-blocking, if you will, way to access threads, or it limits the thread contention significantly. So we have an atomic reference for the location, for the write location. We have an atomic reference for the read location. So that's where I'm at for the write. This is where I'm at for the read. We go down here, and we're going to track what ring number we're on, and we're going to track what write ring number we're on. So we have a read ring number and a write ring number, and we have to make sure the read is always behind the write, because otherwise we need to block or stop or return null. Read index 0 is where we start, write index 0, so we're going to start from 0. Here we have a write object. First thing we're going to do is we're going to get the read location, right? So as far as the write is concerned, it can't write if the last item wasn't read yet, so we need to know where the reader's at. So if the write ring number minus 1 is equal to the read ring number, that means the read is 1 behind. And as long as the write index is less than the read index, then we go ahead and write to that location. Otherwise, we just make sure that the write index is greater than the read index. And we're going to have logic in here to make sure that the read is only 1 behind the write. That will be on the read side. So notice that we're only updating and accessing the write variables, not the read variables. And that's because the thread that's going to be doing the writes will only see the write variables, because it's only going to be updated by that thread, where the thread that's doing the read is only going to see the read variables, and it's only updated by that thread. And if we need to read the other side, whether that be we're from the write and we're reading the read locations, or we're from the read and we're reading the write locations, we're going to access this atomic reference. Remember, these are both atomic references. We have one for write location and one for read location. Let's see here. If for some reason we could not write, we're just going to sleep for 10 milliseconds, and we're going to try again. So it's recursive. Just keep trying until it can write. Again, good for an example. Probably would do that differently if this were real code or hardened code with lots of tests for edge cases. This is not that yet. Maybe one day. It all starts as a proof of concept. So here we have a write index. We're incrementing it. If the write index is equal to the ring length, then we have to set the write index to 0. That's going around that ring, right? And then we have the write ring number plus plus. So that's if it's at 0, then we need to increment the ring number, and then we set the new location. Okay, so for the read object, similar, we're going to grab the write location, make sure if the ring number is less than the write ring number, and then just read. We're behind, obviously. Should only be 1 behind, but we're behind. Else, if the write ring number is equal to if the read ring number is equal to the write ring number, and the read index is less than the write index, then go ahead and read. If neither one of those conditions are true, just return null. There's nothing written that you can read yet. And then you're going to increment the read index, and then if it's the length of the ring, then we're going to set the read index to 0. That means you've reached the end. If it's and then we're going to increment the ring number by 1. Now, both of those together should mean that the read is always behind the write. So I wrote a little example here. Call this main ring. And in this example, we're going to run this again. 30 million records. Track our start time. We grab an executor service. It's a latch. Everything should look familiar. We have a writer thread. We're just writing the object. So instead of calling, what was the thing that we called add and offer, we're just going to call write object. And when we're done, we're just going to print out that we're done, so that we know that we're done. And then we have our read. We're going to read. And then again, don't need this. That was a little extra. It's a little extra. So every time that's not equal to null, we're going to increment our latch. And we're going to read it again. And if it is null, we just sleep for 50 milliseconds. We could do better than that, but that's good for now. And then we read it again. And then if it's null twice, even after 50 milliseconds, we break. And then when we're done, the reader's done, then we're going to wait. And then if the count went to 0, we're going to measure what that count is. So let's just go ahead and run that. And right off the bat, we are saved about what? So went from 3 seconds to 2 seconds. So instead of using, which I found to be one of the main, the fastest of the queues when I was using them in the past, is this link transfer queue. It doesn't do the blocking, so there's only so many positions and whatnot, so that you can kind of synchronize the two threads. But it does. It is the fastest that I've found. There may be faster, but it's really fast. So it's doing about 10 million records per second, and this one is doing about what? 10.5 million records a second. So that's quite an improvement from 3 seconds to 1 second. Let's run that again. See, about 3 seconds. You run this one. That's the ring buffer that we just went over, and that is 2.2. So that's 0.9 seconds faster. That's significant when it's only 3, right? 0.9. If my car went 100 miles an hour and suddenly it could go 160, that would be pretty impressive. Now, the hook here is I've got 2 ring buffers, the one that I showed and the one that I haven't showed yet. And let's call the second one the optimized one. So let me run this after I optimize it, and then in the next thing we'll talk about what optimize. So look, cut off another second. Try that again. Ooh. So it's now 30 million or so a second. That's not bad. How did I do that? Well, tune in next time and I'll cover that ring buffer, and then we'll go back and we'll talk a little bit more about atomic references and the built-in queues and what they're good for and that sort of thing. So if you found this interesting, tune in next time. We'll talk about the second ring buffer, and we'll talk about a little bit more about atomic references and the concurrency API. So what we're really talking about here is I want to be able to produce these videos fairly regularly. Obviously, there'll be some improvements. I know right away that I need a microphone. I had a microphone, and I think one of my kids borrowed it, and it never made its way back. I ordered a new microphone so that we just get better audio. I noticed that the audio wasn't the best. Just making slight improvements like that, so the audio, maybe more outlines, so I know I'm going to say ahead of time, and it's just going to get better with time. So I don't want to wait until I'm good at it to start producing. So I'm going to put some of this stuff out there and then try to get better at this as I put stuff out there, and not wait until the end. Like today, there's a guy building stuff at my house, so there's going to be banging in the background. Not ideal, but I'm going to keep it going and keep the production going and keep things moving forward. So let me know what you think and give me some ideas for future projects, and I'm going to try to queue up a few ideas, and then people can tell me what they're interested in, or nobody. This could just be me pissing in the wind. Probably not, but we'll see. You never know.